With Poisson probability distribution now, one of the biggest difference now is that we are measuring the number of occurrence of a particular outcome of a discrete random variable, but this time now we are looking at in a predetermined time, space, or volume of interval. So some of the example that you could look at is, let's say if you are looking at the number of breakdown of a machine in a, for example, 8-hour shift. So we see that here we have a predetermined time, so we're looking at the number of breakdown of the machine in that time. Or you can also be looking at the number of cars arriving at a parking in 1 hour time interval. Again, you see that we have an interval and we have some of the time. You have time as well here. Another thing as well, I think it has to do with time again. If you're looking at the number of sales that are made by an employee in a week, that could also be an example of what would fit for a Poisson distribution. Something else maybe closer to home science, maybe the number of particles of chlorine in 1 liter of pool water. So this is a volume again, and so yeah, so this is what you would see in a Poisson question, and the formula is also different now, so pay attention. This is the formula here. For x, we know it could be either a discrete number 1, 2, or 3, and where we know that a is the mean number of occurrence given the outcome, and e here, this is a mathematical constant that we call lambda. You should find it in your calculator already, and x is the number of occurrence of a given outcome from which the probability is required. So this is how you do a Poisson. Maybe let's look at a question. Let's solve this question so that things become more clear. Okay, so here is a question that will more or less explain or help us know how to work out a Poisson probability distribution. Feel free to pause at this time to read the question, and we should come back to it in a few minutes. All right, now let's look into depth now. From this question we see that we've been asked, one, what is the probability that on a given day the agency will receive only 3 web-based search inquiries? The first thing that I'll do is just to make sure that this question meets the criteria for a Poisson question. One, I'll see that the random variable is discrete, because the website, or the agency can only receive either 1, 0, 1, 2, or 3, and so on inquiry. There's no such thing as half inquiry. So the data here is discrete. The second thing, we can see also that the random variable has been observed in a predetermined time, so which is per day. We have that here, so it has been observed in 1 day. Then that also fits the criteria. And the other thing we can also see is that the average web-based inquiry per day is also none. So our A here is equal to 5. Then we have everything we need to start answering our Poisson question. So for the first one, A, we are looking for the probability of x equal to 3, when we know that A is equal to 5. All right. Plotting that back to our formula now, P of x equal 3 will be lambda of minus, never forget this minus sign, lambda of minus 5 times a to the power x, so 5 to the power 3 and 3 factorial. So you can plot that on your calculator to get the answer. So you know already what 3 factorial is by now, and let me just write the answer that we have here, and this should give us 0.1404. It's easy to just plot everything on the calculator. Thus we have 14.04% chance, always put that in a sentence like that, chance that the TA, the travel agency, will receive only 3 web-based inquiry per day. Okay? Per day. Or let me rather say that we have 14.4 chance that the travel agency will receive only 3 web-based inquiry on a given day, when the average number of inquiry is 5. I think that's the correct way to say it. So when the number is 5, when the average is 5, the chances of getting only 3 is 14.04. The second question now tells us, what is the probability that on a given day the travel agency will receive at most 2 web-based inquiry for a travel package? In terms of a present question now, at most, at most implies that we'll either have 0 or 1 or 2 inquiries on a given day. Okay, and these events, obviously, they are mutually exclusive. They cannot all happen at the same time. It's either you have 1, 2, or 1, 0, 1, or 2, but at most here is 2. So this means now that we work it out this. Again, we will do the cumulative probability equal to, then we add all 3 probability to find out this one. I'm just going to pause at this moment. Please do that as well. Try to pause the video and do it on your side. I'll also do it on my side, and when I resume the video, let's see if we got the same values. Well, now that I have calculated the probability for individuals, web-based inquiries like 0, 1, and 2, my next step now will be to combine all 3 to get our probability. I'm going to write it now. The probability of x less than or equal to 2 will be 0.0674 plus 0.0337. I'll add that to 0.0842. This should give me now 0.12 464, and this will tell me that we have 12.5% chance that at most two web-based inquiry for travel package will be received by this travel agency on a given day when the average number of web-based inquiry per day is 5. So always put that in percentage and tell me the context. Well, for C, we see that they just told us what is the probability that the travel agency will receive more than 4 web bays. The way this could be written is the probability of X greater than 4 when the average per day we know is 5. Now we have a little bit of a problem, I would say. Well, let's just call it a problem, because since X is a discrete number, so when they say above 4, like more than 4, above 4 means X is 5, right? X is equal to 5. But the problem now of P X greater than or equal to 5 is now we need to find the probability of P X equal 5, P X equal 6, and so on. They didn't tell us where to stop because it could be 5, 6, 7, 8, and so on, right? But the solution is by using again what I called the complementary rule. Complementary rule. So this is what we will do. Now, for this one, we are going to rewrite it in this way now. That above 4, we know that is P of X greater than or equal to 5. We understand that. So P of greater than equal to 5 by our complementary rule means that it's 1 minus the probability of X less than or equal to 4. So remember they told us above 4, so starting from 5 plus, but because we don't know where to stop, we'll rather do 1 minus the probability of 0, 1, 2, 3, and 4. At least we have those one because we know the maximum will always be 1. Therefore, we resort to our complementary rule. So, well, this is our this will be written. Then formally we'll say this is now equal to 1 minus what I've just told you now, P X equal to 0 plus 1, P X equal to 1 plus P X equal to 2 plus P X equal to 3 plus P X equal to 4. Okay, so just to save time, the same formula here applies. You can stop the video and do it on your own time. Let me just write the answers already found so that we save ourselves some time here. Well, I've just individually worked out the probability of all these. Most of them we had them already from our previous question. Now I'm just adding them together, which gave me 0.4405 minus 1. Then this is 0.5595. When I put it in percentage, I have 55.95%. So this just means that we have 55.95% chance that the travel agency will receive more than 4 web-based inquiry for the travel package on a given day when the average number of web-based inquiries is 5. The last question now will require us to read carefully. When they say that what is the probability that the travel agency will receive more than 4 web-based inquiry for travel per package in any 2-day period? Now we knew that our A was equal to 5 per day on average. Because they've said now that we have 2 days, which means now our A, this one has become times 2. Okay, has doubled. Now 2 days, our A will be equal to 10. Always make sure that you pay attention to such detail. Then finding the P of x greater than 4, where A is equal to 10. This is what we are looking for. And we know again that's the probability of x, anything they say more than 4, is just the complementary from what we've just done now of x less than or equal to 4, because more than 4 means that we need to go and do 5, 6, 7 until so on. We don't know where to stop. That's why we go back to the complementary rule. And this is now I'm going to rewrite it again. I'm sure by now you know how this will go. Plus p x equal to 3 plus p again x equal to 4. Then I close my bracket. And the Poisson now will be calculated again. Same thing, applying this formula. I'm just going to pause, let you do it as well, and I'll do it. Then we'll compare our answers later. Just remember now that our A is equal to 10 when you're using this formula. So let's just pause now and do it individually. Then we'll come back to it. Okay, so I've worked out the probability of all this individually, and these are the values here that you see right on top. And what I did, I just subtracted the sum of all this here. I got this final answer, and when I put it in percentage, means that I have 97.1% chance that the travel agency will receive more than 4 web-based inquiry for the travel package in any 2-day period, when the average number of web-based search is 10 per 2-day period. So this is how you work out a Poisson probability.